write the prime factorization of each number. Here is the process. In order to find prime factorization, we need to use our factor trees. First step here is, remember, just give me any two factors that can multiply to give me the 27. In this case, 3 and 9 work out just fine. From there, I circle what's prime, and I break down what can still be broken down. 9 is also 3 times 3. Anything left to break down? So the prime factorization of 27 is 3 to the third. Okay. Does it matter what you use for this first set? As long as it gives us what we're looking for. Okay, any questions on 1 through 4, prime factorization? Remember, use exponents, and they must be in numerical order. Good. Right, Caleb, you got it? Numerical order? Okay. 5. GCF. Okay, so from here, we're going to do factor trees for both 5 and 5. That's 5 times 15. So here is the step that you're really going to need to focus on. If I were just doing the prime factorization, I would use exponents, but for GCF, remember, it's probably wiser for us to just write them out this way, and then you'll see why. And then for 75, we have 3 times 5 times 5. Okay. Now with GCF, once I have them all lined up, what am I looking for? Mia. Numbers in common. So they both have a 5. Once I circle it, I write it down. Do the 5s have to be right on top of each other? No. It's a 5 is a 5 is a 5 is a 5, right? And here's another 5. Once I put another one down, it doesn't mean 55. It means 5 times 5, which is my GCF is 25. Right. So your greatest common factor would be 25. Okay, so the biggest thing here, remember, probably easier to write them out the long way. Okay, and then look for what they have in common. 9 through 12, write each fraction in simplest form. Let's do 11. Not 9. 8xy over 16y. We want to simplify this. We've often said, let's keep the integers and the variables separate. So how are we going to simplify 8 over 16? 1 over 2, right? Yes? Now, x, y, and y. I've got no other x's on the bottom to cancel out, so I need to make sure that that x stays where? On the top. And what about these y's? I can cross them off if they're both the same. So my answer, 1x over 2, or just simply x over 2, either way. So as you look at number 12, 12a squared over 2ab, the 12 and 2 simplify to what? 6 over 1, right? The 6 has to stay on top. And then you have how many a's on top and how many a's on the bottom? So where are there more a's? By how many? All right. And then you have no b's on top and one on the bottom. You need to make sure that you have one of them on the bottom. Yes. Well, where would you put the B? Do you have any B's on top? Do you have any B's on the bottom? So where would you put the B? There you go. You have two A's on top, one A on the bottom. Where would you put the extra A? Where do you have more A's? So you should have? Sounds good. All right. LCD to determine which fraction is greater. Oh. Oh. We didn't do this one. All right, this will be good. And then we'll stop. 3/5 and 8/15. Basically, what they're asking for 13 is they're asking to find out which one is bigger. You've done this before. So they say use the LCD to determine which one is bigger. What is the LCD? Good. So which one are we going to look at, the 15 or the 5 to determine that? The larger one, right? So does 15 also work for 5? So let's convert this to 15ths. Leave that alone. So the bottom number was 5 here. To get from 5 to 15, we had to multiply by 3. So multiply the top by 3. Six, 9. So 9/15 or 8/15, which one is larger? So therefore, the 3/5 would be larger than the 8/15. So 1 through 16. Monday. That's it. Don't worry about the 5 through 8 where it says tell whether they are relatively prime. Don't worry about that. We just do it. So 1 through 16. As long as you do it quietly.
It's my poster because I wasn't here yesterday.
Yeah.
It's due today. Can I quietly go back there and grab it?
If you were like a ninja.
Okay.
Algebra. Yes.
Oh, snap.